Welcome back, learners. I'm Mr. Saul, and today we're going to take a closer look at absorbed light. Absorb means to take in and hold something, the way a sponge will absorb water. Well, light can be absorbed too. As we know, light is a type of energy, and energy will travel from its source and spread out and move around. Well, when light does that and it hits something, it will usually bounce off. This is what we call a reflection, if you remember from our previous lessons. But not all light will get reflected. Now remember, white light is made up of all the colors of the rainbow put together. When that white light bounces off of something, not all the colors will get reflected the same. That's because the colors are slightly different. For example, with this flower, it looks bright orange to us because that is the color that is being reflected off the flower. All the other colors of the rainbow are being absorbed. So let's take a look at it like this. I'm going to put my flower up on the board here so we can see. So here's us, Mr. Saul, and he is looking at the flower. Well, the light that's hitting it is coming from the sun. And that is white light that contains all the colors of the rainbow. Remember, white light has red, orange, yellow, green, blue, purple, violet. All of those colors are in here. But when that light hits this flower, the only color that will be able to come off is this orange. And that's the only color I see. All the other colors, the red, the green, blue, even the purple. All of these colors will go into the flower, but that flower will take them in and absorb them and hold them in place. Remember, absorb means to take in and hold. So just like that sponge sucking up the water, this flower is sucking up all of these other colors. The green, the blue, the red, yellow, all of that gets absorbed into the flower. But that flower can't absorb all the colors. There's one color that will get reflected or will bounce off of the flower. And that is the orange, the color that we see with our eyes. All the other colors are getting absorbed and held in by that flower. And that makes it look orange to us, but really orange is the only color that this flower cannot absorb. And this is how all colors work. Any color that we see is absorbing all the colors except for the color that we see. So if something is red, then it's absorbing all the colors except for red. If something is green, like a leaf, it's absorbing or taking in and holding all the colors except for green, which will be bouncing off of that green color, like a leaf. So this is also why white colors appear white, because they are equally reflecting all of the colors of the rainbow, so it stays looking white. And this is also why black colors appear black to us without any color, because something that is black will absorb and hold all of the colors. There won't be any colors that bounce off of something that is black, so it looks like the absence or all the colors are missing, which is what black looks like to us. So let's take a look at this stop sign. What colors do we see in the stop sign? What colors are being reflected? Let's pause and take a moment to share out and describe what is happening with reflection and absorption of colors on this stop sign. Welcome back. Now, it's very important to remember that energy cannot be created or destroyed. It can only change form. So all these things that we're talking about that absorb this light and then hold it in, that energy does not stay as light energy. It has to change into something else since it's being held by this thing. Well, what it'll change into is heat energy. This is why things that are white will heat up more slowly and things that are dark will heat up much more quickly, because those dark colors will absorb that light and turn it into heat, which then makes it warm up faster. This is why in a parking lot, the black part of the road is much hotter than the white lines that have been painted. Those white lines are reflecting light and it won't warm up. Let's take a look at this experiment that I've set up outside. As you can see, I have my 2 pieces of paper and I'm going to set these 2 ice cubes on each piece. Now I'm going to leave it alone for about 30 minutes and then we'll come back and check. Now what I want you to do is make a prediction. Which ice cube will have melted faster after about 30 minutes? The ice cube on the white paper or the ice cube on the black paper? Welcome back. Let's go outside and take a look at our experiment and see what's happened. All right, let's have a look at how our experiment went. I have the ice that was on the white paper right here and the ice that was on the black paper. Let's take a closer look at which one is larger. As you can see, the ice that was on the white paper is clearly much larger than the ice that was on the black paper. Now, who can explain why the ice that was on the white paper is not as melted as the ice that was on the black paper? Welcome back. I hope you had some really great ideas about why absorbed light will heat up more quickly on the black paper than on the white paper. And I hope you guys learned a lot about absorbed light, and I will see you guys next time.